marked a breakthrough in volcanology. For the first time ever, scientists have discovered a massive breathing structure beneath Campi Flegrei, a supervolcanic caldera near Pozzuoli, Italy, a system that has been quietly restless since 2005. Imagine a crack deep beneath the earth, stretching a kilometer long, hundreds of meters wide, just 35 centimeters thick, yet acting as a massive gas-filled conduit, linking molten magma kilometers below to the fumaroles at the surface. This is not science fiction. It is the heartbeat of a living, breathing volcano revealed through seismic signals, known as VLPs, or very long period signals, first detected at Campi Flegrei in 2018. Picture this: a quiet caldera, towns bustling above, people walking along the seaside promenades of Pozzuoli, unaware that beneath their feet, the ground is slowly inflating centimeters per month, while 900,000 residents live in one of Europe's most complex volcanic systems. Between 2014 and 2025, more than 136 of the largest earthquakes shook this area, each leaving subtle yet detectable fingerprints in the ground's vibrations. Using advanced moment tensor inversions and waveform similarity analyses, researchers from the University of Pisa, INGV, and Germany's GFC discovered that these tremors triggered VLP signals, which in turn revealed the structure's geometry, depth, and function. The breathing structure lies approximately 3.6 kilometers below the surface, directly beneath the Solfatara and Pozzuoli fumarole fields. Visualize a crack-like fracture, fluid-filled, resonating like a tuning fork whenever an earthquake wave passes. Its frequency is astonishingly stable at 0.114 Hz and has remained so for 7 years. This isn't random. It indicates the geometry and fluid conditions are stable, the pressure is controlled, and the system is effectively venting degassing emissions safely. Giacomo Rapagnani, lead author of the Nature Communications Earth and Environment study, explained, "We interpret the VLP signals as the resonance of one or more fluid-filled, crack-like structures connecting the deformation source at depth with the fumarole locations at the surface. This oscillating, gas-filled structure offers a path for degassing." Imagine monitoring equipment, some installed as recently as June 2024, recording data in real time, GNSS stations capturing ground uplift of roughly 2.5 centimeters per month, seismic networks tracking hundreds of micro-earthquakes, thermal sensors measuring the 160 degrees Celsius steam vents at Solfatara's Boca Grande and Pozzuoli's so-called soffione bubble, a continuously expanding mud pool emitting CO2 at rates approaching 600 tons per day. All these instruments converge to show a controlled but highly active volcanic system where the breathing structure acts as a safety valve, preventing dangerous pressure buildup while signaling when the system is responding to tectonic stress. Now, let's focus on human impact. In May 2024 and June 2025, the area experienced M4, 4, and M4, 6 earthquakes respectively, the strongest events recorded in this unrest period. Local residents reported shaking furniture, cracked plaster, and boats running aground in Pozzuoli's port due to minor tsunamis triggered by the seismic activity. Schools conducted emergency drills, and civil authorities heightened alert levels, yet the majority of citizens remain unaware of the underground processes. Set the stage for a story of scientific discovery intertwined with human vulnerability. The breathing structure is a living reminder that Campi Flegrei is far from dormant. Its VLP signals are not just data points, they are a message from deep below, a pattern repeated for 7 years, a consistent pulse of a system in tension but not yet crisis. As we continue, You'll see how these signals reveal the volcano's plumbing system, the exact pathways for gas and fluid migration. As we delve deeper beneath the surface of Campi Flegrei, the story becomes even more fascinating and slightly unnerving. How does the breathing structure actually work? What do these VLP, or very long period, signals tell us about the magma and gas movements deep underground? Imagine waves so slow that one cycle lasts almost a full minute and a half, 60 to 120 seconds, yet they carry the secrets of the caldera's plumbing system. Since 2018, more than a dozen of these VLP events have been recorded, all beneath Solfatara and Pozzuoli, but never before had scientists been able to map the exact structure responsible. Here's where it gets remarkable. Each VLP signal resonates at a constant 0.114 Hz, like a massive natural tuning fork vibrating silently beneath the Earth. Unlike typical earthquakes, which release sudden bursts of energy, scientists used advanced waveform similarity analysis and moment tensor inversions to understand the mechanics. They noticed that VLP amplitudes increased temporarily after deeper VT earthquakes, indicating a direct coupling between tectonic stress and fluid movement. Dr. Simone Seska from GFZ Germany explained, "The waveforms have remained remarkably stable for 7 years. This tells us that the geometry of the fracture and fluid properties are steady, acting as a reliable degassing channel rather than an unpredictable risk." But here's the question for you, our viewers. If a fracture like this lies directly beneath densely populated Pozzuoli, do you think local authorities should simulate evacuation for a scenario where the degassing pathway becomes blocked? Drop your thoughts in the comments. Would you feel safe living above a volcano that literally breathes? This is exactly the kind of discussion volcanologists hope to inspire: awareness, engagement, and proactive thinking. Visualize this with a 3D cross-section. The crack originates 3 kilometers deep at the main pressure source, connecting to surface fumaroles, where CO2, steam, and heat escape. Thermal cameras at Solfatara show Boca Grande venting at 160 degrees Celsius, while Pozzuoli's Soffione emits a continuous stream of mud, gas, and heat. The VLP signals, in essence, are a direct measurement of the system's health, a heartbeat of pressure release. The resonance frequency stability is critical. Any change in the 0.114 Hz oscillation could indicate geometry shifts or fluid property changes, potentially hinting at increasing volcanic risk. In other words, these vibrations are more than scientific curiosities. They are early warning signals. The question we leave for you: if you notice this system suddenly skip a beat, how quickly would you want authorities to alert you? Comment below, would you want a mobile alert system specifically for this kind of underground activity? This part of the story combines data, observation, and human experience. The combination of advanced seismology, tomography, and real-time monitoring transforms abstract vibrations into actionable insights. Now, let's finally uncover the breathing structure itself. Imagine a crack deep beneath Campi Flegrei, 3.6 kilometers underground, stretching a full kilometer long, 650 meters wide, yet astonishingly thin, just 35 centimeters thick. This is no ordinary geological feature. It is a fluid-filled, gas-rich fracture connecting the deep magma chamber directly to surface fumaroles at Solfatara and Pozzuoli. Visualize hot steam rising through this narrow, crack-like pathway, venting safely to prevent dangerous pressure buildup. Scientists call it the volcano's heartbeat. Each VLP signal is a pulse, oscillating at 0.114 Hz, unchanged since 2018. Think of it like a giant organ pipe. Even small earthquakes make it resonate, but the structure remains remarkably stable, constantly releasing pressure while sending vital clues about underground stress. Dr. Giacomo Rapagnani explains, the oscillating gas-filled fracture connects the deep deformation source with fumarole locations. Now, here's a question for you. If you knew a fracture like this ran directly under your town, would you feel reassured by its stability, or anxious knowing it channels magma and gas from kilometers below? Drop your thoughts in the comments. This is exactly the discussion scientists want the public to have. At the surface, this breathing structure fuels Solfatara's 160 degrees Celsius steam vents and Pozzuoli's soffione, emitting hundreds of tons of CO2 daily. These emissions are the visible signs of the underground pulse, the volcano literally breathing under our feet. As we approach the surface, the story of Campi Flegrei's breathing structure becomes both awe-inspiring and cautionary. The VLP signals we've discussed are not just abstract scientific data, they are living evidence of a volcano that communicates with us. The fracture sits directly beneath Solfatara and Pozzuoli fumaroles, two of the most active degassing zones in the caldera. Visualize thick plumes of steam rising from Bocca Grande, reaching 160 degrees Celsius, while the Pozzuoli soffione churns mud and gas continuously. This is the visible surface expression of a structure that stretches a kilometer below. Every gram of CO2 vented roughly 600 tons per day traces its path from deep magma, through this natural conduit, to the atmosphere. Monitoring is critical. GNSS stations at RIT record ground uplift of 2.5 centimeters per month. INSAR interferograms show the deformation center offshore, and seismic heat maps highlight hundreds of small earthquakes every month. Thermometers in fumaroles track temperature spikes, while gas flux sensors measure CO2 release. Together, these tools provide real-time insight into the health of the volcano, but they also raise urgent questions for you. If the VLP frequency changed tomorrow, signaling potential blockage or stress accumulation, how would your family respond? Would you have an evacuation plan ready? Drop your thoughts in the comments. Would you trust local authorities' alerts, or would you take proactive steps?